13.3. It's similar to the voting method approach, because in the voting method, there's 4 different approaches. And for the apportionment, there are also 4 different methods. And these individuals here with these names, this Hamilton's method, this is the guy. This is the guy that Alexander Hamilton, the one that they named the play after, the one that appears on the $10 bill, the president. That's the guy. He also dabbled in voting and the Electoral College. Jefferson, yeah, this is the guy, Thomas Jefferson, one of our presidents, writer of the Declaration of Independence. John Adams, another guy back then. They all had ways to work on this apportionment problem. And Webster was also a founding father back then. Never made it to the president, but. And their math problem was, okay, we have all these states. There's different sizes of the population in these states. They wanted to form a representative government. And so they said, you know, we have 538 electoral college votes. And so we have 50 states. And each state has 2 senators. So that's 100. So there are 538 electoral college votes. They break them down by the states in terms of the senators. So now we have 438. And then they give a 3. DC is not, Washington, DC is not really a state, but they give them 3 representatives, 3 electoral college votes. So that leaves 435. All of these are allocated to the 50 states based on the population. So what you're going to find is California has a huge number of folks out there, you know, 39 million or something like that. It's the most populous state of all 50. So they're going to get a big chunk of these. But we're going to award these electoral college votes based on the population of the state. And every 10 years, we have a census. And maybe you just filled that out, or maybe your parents did, or someone else in your household did, to determine who lives in that house so that we can determine the population of each state. And then the results of the 2020 census will then lead us to change our current configuration in terms of the number of number of representatives in the House of Representatives and the number of electoral college votes. The Republic of Amador is composed of 5 states, A, B, C, D, and E. All right, so it's just too cumbersome to write, you know, 1 through 50 states here. So we're using a much simpler problem, and we just have 5 states. And there are 200 representatives in their Congress. So we need to award 200 voters, or 200 seats to the Congress. So the sum of all these numbers here is going to equal the 200 in the end. That's how many people we want in our Congress. All right, so the standard divisor is the first thing that you're going to calculate. And the standard divisor is the total population divided by the number of seats. So in this case, we're going to take 10,000, the total population, and divide by 200. And that's going to be 50. So the standard divisor is 50. The standard divisor is related to the standard quota. So the quota would be how many of these 200 votes is state A going to get? And you can see that the population of A and B are about the same, so they should get about the same number of votes. C is a little bit higher than that, D is a little bit higher than that, and then E is like our California. It's got a huge number of individuals there, so they're going to probably get more. They have almost half of the total population, so they're probably going to get close to half of those 200 votes. It's all based proportionally. All right, so what we're going to do is we're going to take these numbers, each one, and we're going to divide by the standard divisor, this 50. So 1112 divided by 50, and then 1118 divided by 50, and then 1320 divided by 50, and so on. And then finally, 4935 divided by 50. And you can see it's very close to 100, 98.7. So this is the first thing that we're going to do. And so you can see here, if you just lop off the decimal pieces there, you've got 22, 22, 26, 30, 98. When you add all those up, you get something close to 200, but it's a little bit less. So this whole problem is to figure out where are those fractions going to go to as whole numbers. All right, once you have the standard quota, then you're going to calculate the lower quota and the upper quota. The lower quota, what we do is just get rid of the decimal piece. So get rid of the 24, even if it's a large number like 0.7, just get rid of it. And then the lower quota would be the integer part of these numbers. So if I get rid of the decimal, 22 is the lower quota. If I get rid of the decimal, 22 is the lower quota, and so on. 26, 30, and 98. Now the upper quota is all similarly fairly easy to calculate. What you do is you just take this number and round up instead of rounding it down. Take this number, round down to get the lower quota, take this number, round up to get the upper quota. Another way to say that is whatever the lower quota is, add 1 to it to get the upper quota. Plus 1, plus 1, plus 1, and plus 1. We do the lower quota and the upper quota because we say something like this. If this is fair, then a state is either going to get its lower quota or its upper quota. We don't want a state to have an upper quota of 23 and then have them get 24. That means they're getting too many votes. So we don't like methods that violate what we say is the quota rule. All right, now, so this stuff that I'm doing here, this is all preliminary stuff. This is before we get to the 4 methods: Hamilton's, Jefferson's, Adams, and Webster's. All right, so I'm going to add these together: 22 plus 22 plus 26 plus 30 plus 98, and we get 198. And that means since all these are 1 higher than these, you can add 5 to that, and you should get 203. In this chart here, the only totals that will not sum to 200 are the lower quota and the upper quota. All of these other methods, they're methods that apportion the 200 seats. So these numbers have to add up to the 200. These have to add up to the 200. Moreover, these have to be whole numbers, We can't assign a fraction of a senator. Okay, so the first method, Hamilton's method, it's described up here, so you can read it later. But what we're going to do is calculate the standard quota. Did that. Round each state's standard quota down to the nearest whole number. That's what we did here. That's the lower quota. And so we've given away 198 of the 200 seats. So that means we have 2 more seats to give away. The question is, to which of the 5 states are we going to give those last 2 votes? Seats. And here's how Hamilton's method says we're going to do that. We're going to go look at the decimal piece of that standard quota. And since we have 2 votes to give away, we're going to give those 2 votes to the 2 states that have the highest fractional part in their standard quota. So I'm just going to put zeros on there. It's easier to tell. So when you look at these decimal pieces, 24, 0.24, 0.36, 0.40, 0.30, and 0.70, which of those decimal pieces are highest? That is, which one is closest to the next whole number? And if you had to rank them, 70 is the highest. After 70 comes 40. And then after 40 comes 36, and then 30, and then 24 is last. So this is how we would rank the decimal versions, the pieces that are left over. All right, so here's what Hamilton's method says. Take the state with the largest fractional piece, which would be state E here, and instead of assigning them their lower quota, we're going to assign them their upper quota. And so E gets one additional. We have to give away 2 because we've only given away 198 seats at this point. So we've given away 1 with E. If you're following here, write in the chat box, who gets the second vote, the second seat that we're going to give away from the 198. And give an extra vote, 1 at a time, to the state with the largest decimal part in their standard quota until all the electoral votes are allocated. Okay, 70 was first because the decimal 0.70 is the highest decimal. The next highest decimal is 40. D, the decimal piece, is 30. So we're focusing in on the decimal piece, not the whole number piece. So we would give the second vote, not to D, but we would give it to C because C has the closest to the next whole number. It's got 0.40 versus 0.30. So that's why I put these numbers here. So the next vote we're going to give away is to vote C. So instead of using the lower quota, we're going to use the upper quota. And there's the extra vote. Everybody else gets their lower quota. And those then will add up to 200. And that's how we award the seats. And those 4 numbers will add to 200, and we have a fair division of seats. It's called Hamilton's method. All right, the next method is Jefferson's. Here's Jefferson's method. His method is to select a modified divisor. And this modified divisor is actually going to be less than the standard divisor. So this modified divisor is going to be less than or equal to 50. I suppose it could be equal to 50 is what it says here. Now, in some of your problems, that modified divisor is going to be given to you. All right, so we're going to choose a modified divisor. If it works, great. If not, then we choose a different one. But the modified divisor that's selected has to be less than the standard divisor of 50. So let's just say that it's 49.3. Now, instead of having to divide all of these populations by 49.3, you're going to find that using the lists in your calculator will be very helpful. So clear out your list and enter in the populations. There's only 5 numbers, so it's not too bad. I don't know if you remember, but when I got these numbers on my home screen, I divided every single one of them by 50. I repeatedly divided by 50. And I want to try to avoid that. And to avoid it, especially because you're going to be experimenting with different D values as you go through this. So once you get these typed into your list, then highlight list 2. The first thing I'm going to do is I'm going to divide by 50 so that you can see these numbers here. To do that, I'm going to highlight L2, and then down in the input row here, I'm going to do second and then the number 1 to get L1, and I'm going to take the number in L1 and divide by 50. If I put a formula down here, then it's going to take all of those numbers and divide by 50. And you should recognize those: 22.24, 22.36, and so on. All right. In this example, we want to divide by 49.3. So again, highlight L2, and then down in the input row, take L1 and divide by 49.3. And then we're going to write down those numbers. All right, you can see it, 22.56 is how they rounded the first one. But let me write these other ones in here. 22.6, I'll round them to 2 places. 22.68 and 26.78 and 30.73 and 100.1. All right, now the next step is we're going to round down. So here's 22.6. They've done this first one for us. If you round down, that means just truncate the decimal part off. 22.56, even if it was 22.99999, when you round down, you go down to 22. So basically, we're going to just get rid of the decimal piece in this method. 22, 26, 30, and 100. And if you add those 5 numbers, you'll get 200. Now, Jefferson's method was not approved by a lot of folks because of what you see here. We said back here that, to be fair, we don't want to give someone more votes than they deserve. So they should either receive their lower quota or their upper quota. And you can see, using Jefferson's method here, that using this method, that state E actually had more seats than their lower or upper quota. Every other state had 30 or 31, 26 or 27, 22 or 23, 22 or 23. But this one is one we would say violates the quota rule. But that's what the method gives us anyway. That's Jefferson's method. Choose a divisor, modified divisor, that's less than the standard divisor. And then divide all the populations by that D, and then round down. Adams' method kind of does the opposite. So now we want to find a modified divisor that's larger than 50. And so the number chosen here was 50.65. In a real life situation, you would actually have to come up with this number. What is the number larger than 50 that we should choose so that we allocate these 200? All right, so again, I'm going to go to the calculator. And since the new divisor, we always divide by the divisor. So if the divisor is 50.65 in this method, we're choosing a number larger than 50. So instead of rounding down, which is what we did over here in Jefferson's method, we're going to divide by a larger number, making the quotient smaller, but then we're going to round up to make them bigger, kind of undo. So again, highlight L2 right here, and then down here in the input row, we're going to take the numbers in L1 and we're going to divide by our new divisor, 50.65. And we get these numbers. You can see the first one, 21 point, I probably would even call that 21.96. 22.07, 26.06, 29.91, and 97.43. So all these numbers here, L1 divided by our new divisor. Okay. Now for Adams' method, once we get these modified quotas here, Then we're going to round up. So whatever the integer part is, add 1 to it. Add 1 to 21, add 1 to 22, add 1 to 26, add 1 to 29, and add 1 to 97. Basically take these numbers and round up. Even if it's 22.07, if you would round this mathematically, it would be 22. But in this method, we're going to round up, so it goes up to 23. 26.06 goes all the way up to 27. Sure enough, if you add these 5 numbers, you're going to get 200. Does any of them violate the quota rule? 22 or 23? Good there. 22 or 23? Good there. 26 or 27? Good. 30 or 31? Good. 98 or 99? Good. So there's no violation of the quota rule here. So Adams method. Find a modified divisor greater than 50. Divide all the populations of each of the states by that modified divisor, and then round up. Round up. Apportion to each state its modified upper quota, as we've done in the table. Okay, so the fourth method is called Webster's method. And for this one, they're not going to tell you what to choose. You can either, sometimes a divisor less than the standard divisor, less than 50 would work. Sometimes a divisor greater than 50 would work. You really have to do trial and error to figure out which one's going to work. And for this method, they chose one that was actually smaller than 50, 49.8. And so we're going to divide all of the state populations by this new modified divisor. Write the decimal in here. Then the rounding is different. I don't know that I like the way that they describe it here, but round 4/5 means round mathematically. That is, if the 10th digit is a 4 or less, you round down. And if the 10th digit is a 5 or higher, then you round up. So round mathematically is what this means. So again, we're going to go to our list. And we're going to take all of these numbers in L1, and now we're going to divide by the divisor that they've given us here, 49.8. And we're going to write all the decimals there. There you see the 22.33, and then we have 22.45, and 26.506, and 30.422. And then 99.096. So there they are. And then we round mathematically. So if you round this mathematically, you see a 4 there, so we're going to round down, and state B gets 22. You can see that this one would round mathematically to 22. This one here, 26.5, since the 10th digit is 5, we're going to round up to 27. This one here is 30, and this one here is 99. And sure enough, when you add those 5 numbers, you get 200. Now the difficult, and that's the fourth method, and it's described here. The difficult part about this whole thing is trying to decide what these numbers here are. And if you choose one and it doesn't work, you have to choose another. So if 49.8 did not work here, I'd have to go back and maybe divide by something else. And then I'd get these numbers, and then I'd round them up. This one rounds to 23, 23, 27, 31, and 100. And so if I just choose any old arbitrary number and I added those up, which are the rounding versions of these, you would see that I'm at 204. I'm way over the number that I can allocate.